All right, so what we've already noticed is that once you create a file, writing to it, you just use the less than signs, just like we do when you're sending something to the screen, right? Using namespace, std, let's # include string, let's # include fstream so that we can use files. All right, and so if we open an output file, right, that's an ofstream. I'm going to call it fout, just like cout, and then fout.open, right, file.txt, and then I can send something to it, right? Hello world. Looks just like the other one. Then you can close it. fout.close. Now what we should really do is to make sure that the file is open first. And so we can do if fout, meaning if the file was created, then go ahead and write to it. So that would create a file with the text hello world in it. So now if I go and look for that file, it's going to be in the same directory as my source code. So I'm just going to right click on it and do open folder in File Explorer and go into the source code directory. And there it is, my file.txt, hello world. All right, now that's not that interesting. So let's do something a little bit more interesting than merely displaying hello world. Like let's write some data out, a whole bunch of numbers. For int I is equal to 0, I is less than 1,000, I plus plus. And we're just going to write out 1,000 numbers to the file. Fout, arrow, arrow, I, arrow, arrow, endl. And it ran pretty quickly. So we can do the same thing. We can open up the file again. And we'll see a bunch of numbers in it. We could automate the opening of that file with a system call. Now, I don't know how to do this on the Mac because I don't know how to generate the the call that would open it. I'm sure you could do it, but on Windows, it's pretty easy. All we need to do is to create a string that has the word notepad followed by our file name, and then call the system call on that. Now I'm going to take this file.txt and put it in its own variable, string file name, so that I can reuse it, right? So string file name equals file.txt, or we could ask the user for. And so then we're going to open the file, right? Whoops, where'd the caps come from? All right, there we go. And now I want to open that file. I'm going to change that to done, right? We don't need to keep saying hello world anymore. But I could put a message here, right? I could display, data saved to file like that, right? That way we just see, a nice little happy message saying that we did save to the file. Otherwise, if it runs and we don't display anything, then the user doesn't really know what happened. All right, now let's build a string that'll let us open that file. So I'm just going to call it CMD. It's equal to the word notepad, end quote, followed by the file name. And then we're going to do system based on CMD dot CSTR. And it didn't do the dot correctly. Here we go, C_STR. Does that need to be parentheses? Yeah, okay. So that looks weird. Everywhere else we've used a string. All we had to do was that. But that's because the system command is not expecting a string object. It's expecting a series of characters. It's expecting a character array, like when we did, system pause or something like that to get it to display a pause message. And that's not really a string. It's an array of characters. And the system call, being old school, written a long time before the string class, is expecting that kind of data. And so to get an array of characters out of a string, you call the C_str function that gets a character array out of it. And why are we doing this? It's just so that when I run it, it'll pop the file open in Notepad when I'm done with it, right? That's kind of cool. So if you feel like doing that in one of your programs where you create a file and write some data to it, if you want to pop it open in Notepad and you're using Windows, that makes it easy to do that. Great. Now, I think that on a Mac, we might be able to do the same thing. We would just have to use a different system call. And I'm not sure what. Text edit? I know of one, but it's really kind of lame. If we use Nano, Nano is a text file editor too. That comes default on Unix and Linux systems. But it'd be nicer if it was, a real program. I mean, a real, a nice, pretty editor. But if you're going to do this on the Mac, you could try it, except you would use Nano here, right? And then it would display the file using the Nano editor. The Nano editor is just a really primitive editor. Looks like this, right? Really old school. So that's a Mac editor. And of course, the Mac comes with fancier editors like TextEdit. But I don't know how to launch that one from the terminal. So that would work for the Mac, maybe. Let's add a comment to that. Might work on Mac. And then for Windows. Okay, so we know how to save data to a file now. We just open it up like that, and then we use the arrows to write to it, just like we were displaying data to the screen. We can do the same thing to read from the file. Now that we have saved our data to a file, let's open it back up. Let's add some comments about what we're doing here. Save data to the file, right? And then now open the file for reading. We could consider moving this code into its own function. To do that, we would need to create some kind of function. It might be Boolean to return true or false based on whether it worked or not. And I might call it write file. And it might take a string file name as its parameter. We would need this variable in it, right? We would need all of this data, all of this code in it. So I'm cutting that and putting it here. This comment could go, right at the very top or something like that. And then when we wanted to write our file out, we would just call our write file function. So down here, write file name. Except I have these in the wrong order, don't I? Needs to be underneath that. There we go. So we've got a function that'll write to the file. We could even ask the user, what do you want to do? Do you want to read from the file or write to the file, right? So cout read from a file or write to a file. Then we need a variable to hold a choice. String choice is equal to, string choice, CIN into choice. And we could have an if statement, right? If the choice is equal to W, then we're going to write to the file. We might even want to ask them for the file name. So let's ask them for the file name. So cout listen, enter file name. And then CIN greater than file name. And then we could write the file out. I'm going to get rid of this initialized value because instead we're letting them type it in. All righty. Then I guess we could check. Else if the choice is equal to reading, then we're going to do something. Else we're going to tell them invalid command, right? Invalid choice. Like that. So let's try it out. Of course, we don't actually have reading implemented, but once we fix our errors here, which I seem to have two, file name is undefined. Well, true enough. So I should have declared the variable outside of this brace because the scope of this variable is from here to here, right? Also, I could just take this code here where we try to open the file and cut it and paste it right here, right? Like that. So let's add some comments here as to what we're doing. Open the file with a text editor after it has been written out using the system function. Let's give it a shot now. Still an error. Write file must return a value. That's true because I defined it as Boolean, right? And so what we're going to do is declare a variable called OK, right? Bool OK is equal to false. And if we get to save our data to a file, we're going to change that variable to be true, right? OK is equal to true. And then the last thing we could do down here at the bottom is return true. See if we can get all that on one screen now. All right. So there's our write file function now, right? Saves data to the specified file name. We set our return value equal to false. We try to open the file. If we get the file open, we go ahead and write some numbers to it. We print a message saying data saved to file. And we set that variable equal to true to indicate that we're good to go, right? Then we close our file and we return our value. Now that was actually supposed to be return OK, right? Because OK might be false. If the file was not created because it had a bad drive letter or bad file name or something like that, then it might not be saved. However, we're not checking that return value. So maybe we ought to go and modify our main code to do that. So here, let's check to see if it was okay, right? Bool okay, now come back. Bool okay is equal to write underscore file. Right, like that. And then we check to see if it's okay. If okay, then we're going to try to open the file. So we're going to take all this code and indent it, right? Like that. If we wanted to, we could even move this code into its own function, but I don't really see why. It might make this code look a little bit cleaner, but meh, I think we're okay. All righty, let's see if it'll actually run. All right, let's write to the file. File name is going to be t.txt, and there's t.txt. And now we're done. We can make it a little bit more sophisticated to check to see if choice was equal to uppercase R or choice equals lowercase r. But I'm wondering if there's a way to convert that string into lowercase so that we would not have to use the or statement. Why don't we Google up C++ string class uppercase. To convert a complete string to uppercase, just iterate all over the string and call toUpper on each one. Oh, really? What are you doing? Stop that. I don't want to create an account. I was happy viewing when I saw there. All righty. Well, yeah, you could use this. I was hoping it was easier than that, honestly. So you can use something called Boost. You could download some code called Boost. That would work. Or you could use string transform. That seems like a lot of effort. I mean, you know, I only have to copy the code, right? So all I have to do is copy and paste that to get it to work. I'd need to add this algorithm here, and then I'd have to do that. Let's play with it just for completeness sake. It should not be that complicated. It's not that complicated in Python, is it? Or in Java. Anyways, we're going to have to add one more # include. And in a minute, I'll send this code out to the chat so everybody can get it who wants it. Right? So algorithm. Let's make a function that does that. Right? So like string make uppercase. And it takes a string as input. Right? And then so let's declare a string called output, which is equal to our input. And then let's run that transform on it. Transform our output dot begin from the very beginning to the very end, starting here. Don't know why we have to do that twice. And then calling toUpper. Then we want to return our string, right? Return output. Maybe we could shorten this to just uppercase, right? Like that. So now when we get our input, we can just call uppercase on it to convert it to uppercase. Now, honestly, just writing the or statement, you know, if equals uppercase R or lowercase r would have been shorter, right? But if I could kind of commit this to memory, I like the option of converting data to uppercase. And in lowercase, obviously, we would just change that to lower. We could copy and paste this whole function and make one called lowercase. I don't even think we need that underscore in here, right? And so then we're going to call toLower on it. All right, so now let's go down here, and after we get our input or output, let's convert it to uppercase, right? Like that. Then we don't need to have an or statement there or there. So I can get rid of this one. All righty. How about reading from a file? We know how to write to a file. We're still going to need a file name. So why don't we do this stuff? And why don't we even do all of that? We're going to wind up changing write to read. So down here, right, we're going to read from the file. And then if okay, we're going to do something with it. I don't know what. Else, you know, just leave that alone. Now we don't have a read file function yet. We're going to go write one. So I'm going to scroll up here and make a read file function. It's going to return true or false, just like the other one. So it needs to accept a parameter. That's the file name. Bool OK is equal to false. This is going to be an ifstream rather than an ofstream. ifstream, fin, right? Not f out, but fin. Of course, the variable names, you can make whatever you want. Now let's open the file if we can. It might not exist, right? So we have to check to see if it exists. Oh, that was supposed to be fin.open, right? There, now we're good to go. But we have to check to see if it worked. So if not fin, that means it failed. Cout, error, could not open, end quote, less than file name, less than endl. And we could return false right then and there. As a matter of fact, if we're going to do it like that, I don't think we even really need to have that there. So now that we have the file open, we could run through it. We could read the data out of it. Now, there's multiple ways of reading file. There's multiple syntaxes. Let's take a look at one of the ones that the book recommends, just for simplicity's sake. Do exactly the way the book does, rather than, that's the wrong one. That's Python. Here's how they do it. They just have a while loop that reads the data into a variable. Let's do that. So instead of being called input file, it's just going to be fin, right? And we haven't declared a variable to hold our data yet, but we will. Let's go do that right now. So while fin greater than data, let's declare that variable. Are we going to read it in as a string, or are we going to read it in as numbers so that we can actually add them up? For now, let's just make it a string. And then for every line we read, let's display it, right? Read from file, colon, end quote, space, less than data, less than endl. Let's see how we think about that. And then when we're done with it, we need to close the file. So fin.close. And we need to return a true, indicating that everything was okay. All right. Now, since it's got 1,000 numbers in it, it's going to take a long time to display it. I'm going to shorten it so that our file is only 100 numbers long, right? So I'm changing that. Now I'm going to run it and make that file. Write the file, t.txt, data saved to file. Right. We have our 100 lines of data there. Let's close it. We could make it loop, right? Might be cool to make it loop. So let's go down to main and do while true. And then we're going to have a closing brace down here before our return statement. Oh, please don't have crashed on me. Okay, right there. And let's ask them what they want to do. Write from a file, read from a file, or quit. And then if our choice is equal to Q, we just need to break, right? So if choice equals quote Q end quote, break. All right. So I'm going to write to the file, t.txt. Close that. Now let's read from the file. Enter file name, t.txt. And it read all 100 lines of data, the numbers 0 through 99. And then it said file read OK, right? We could write to another file if we wanted to, t2.txt. Then we could quit. We could take that code that's popping it open with Notepad and put that as its own menu option, right? Read from a file, write to a file, edit, file, or quit, right? And so if the choice is Q, you quit. Else if the choice is equal to E for edit, then we're going to use that Notepad code. We're still going to have to ask for the file name, right? And then else if there, right? Okay, so let's get the file name. And like I said, this is kind of Windows specific. I need to figure out how to do it on the Mac. I need to pop it open, you know. Anyways, let's take all of this. All of a sudden, our code here is looking pretty skimpy, right? If okay, see out, you know, file written okay. So with that, we see something, right? Okay, so anyways, I'm going to move that using Notepad up here to here. Like that. So now we have our menu choices. Read, write, edit, or quit. Let's edit our file. t.txt. There it is, right? So we could go and change the last number from 99 to 900 and, you know, 9,999. Then we're going to save it. And now that we're going to read from it, t.txt. And there's our data. And we could do something useful with the data, right? We could add up all the numbers in it, you know, if we read them in as digits or whatever. Okay, so I think that we have adequate demonstration of how to do a file IO type program. I'm going to summarize with some notes down here. File IO using the fstream classes, ifstream for input, ofstream for output, how to use them. You make your object, right? Like ofstream fout, and then fout.open, file name. You check to see if it's good. If fout, then you do something with it, else you display an error message. Right? That's how you can send data to a file. Then you need to close it. fout.close. And you could display an error message, right? Cout could not open file name, quote, for writing, right? That makes sense? That's how to use ofstream. Let's do the same thing for ifstream. These are just simpler examples, right? ifstream fin.open the file name. If it worked, great, right? So if fin, then read the data in, right? fin greater than, data, like that. Whatever you need to do. Or, you can make it while fin greater than data. To read it in like that. Tell you what, let's take those things out and just leave that as the recommended way of doing it. Else we need to display an error message. Cout. I'm just going to copy this message, Could not open this file for reading. You can also open a file for appending with ofstream. And I demonstrated that syntax last time. I'm not going to look it up again. All right. Let me send this to you for anybody who wants it. Put it into text file and send it to you. What does this code do? Demonstrates ofstream and ifstream. We're not going to have any homework. You've already got homework for the week, I believe. Why don't we go ahead and plan on taking the exam? Now, the way the exam works is I'm going to give you the access code, and you can just start working on it. If you get stuck, go ahead and send a chat message or just switch on voice and ask a question. And then I'll probably switch screen sharing back on so that you can watch me go and look at the question or whatever, right? And I can try to explain it and everybody will get to overhear the question, right? So it's fair to everybody. That doesn't mean that, y'all get to ask a question for every single question on that, exam, work your way from question 1 all the way down to question 50, right? But you certainly are free to ask questions. Please do. All right, there's the file if you want it. And yes, you can. And I'll make the Dropbox and everything so that you can, put a comment as to what you learned. But let's go ahead and get the exam started. Why wait? If you need to go and take a break beforehand, that's cool. The access code for it is Apple 9. So all you got to do is go into Canvas, and click on quizzes. Although come to think of it, I'll just go ahead and add a link to it right in week 5 as well. Make it easy to find. So let's go into it now. I'm going to open quizzes. Let me slip into student mode so it looks for me just like it does for everybody else. We need exam 1. Take the quiz. Access code, I believe, is Apple 9. Let's find out. Yes, that seems to be the case. All righty. So like I said, you have any questions about it, go ahead and ask. There's a few questions where I just flat out give you the answer, right? And the reason I do that is it's for stuff that we did not cover yet. It's actually in a later chapter, I think, so I'm not sure why it's on this exam, but just in case I want to use it next time, I left it there. Just a few of them. That is for these things. Question 41 and 42, and maybe a couple others. Yeah, and 43 and 44. Right. So those already have the answers. They just flat out tell you. So please don't get those wrong. All right, gang, any questions before we start? I'm going to stop the screen share so that y'all can just start working on it. Please stay logged in until you're done. And then when you're done, go ahead and send a chat message or whatever saying you're done and log out. That make sense? All righty.